Alright, so this time we're going to do another subspace question. Basically, we're going to consider again V being the set of all two-dimensional vectors or two columns. This time the set U as a sentence is the set of all vectors in two space, which consist of vectors with second coordinate equal to 1. And we want to know, is this a subspace? So again, what are we going to do? First, we're going to describe U as a set, and it's a subset of R2, so we can see what it looks like to be in there. We're going to take two vectors in there. We're going to see if we can add them. We're going to see if we can scalar multiply. We're going to make sure it's not empty, and then we have a subspace every time. So first of all, what are we going to do? Let's redescribe what U is. It told us U was the subset of R2 consisting of all vectors which have second coordinate equal to 1. So let's describe that. U is equal to all two-dimensional vectors or two columns such that the second coordinate is a 1, and then I don't know anything about the first coordinate. So such that x1 is any real number. This is a subset of R2. It's all two columns which have that coordinate 1. So we want to know if U is a subspace, this subset of R2 is a subspace of R2. We get immediately that it's not a subspace from condition 1. I'll check the other two conditions just for practice so you can see, but I already know the jig is up. It's not a subspace. This is the easiest one and the first one you should try. If 0 is not in there, it's not a subspace. We have a result that says if you're a subspace, then 0 is in there. So if 0 is not in there, then U is not a subspace, the contrapositive. So we see that immediately 0 is not in there because its second coordinate is a 0, not a 1. So 0 is not in U. So U is not a subspace. We've already done the question. Bang, done. I'll check the other two conditions just in case you forget to show. Everyone forgets to show that 0's in there anyways. So if you're just running the other two conditions, if I take k times a vector in there, x1, 1, then by scalar multiplication this becomes the vector kx1 and k times 1, which is kx1, k. And if k is not equal 1, this does not equal kx1, 1. K scalar multiplication also fails. K times a vector is this guy, which doesn't equal this. It doesn't look the same anymore. It's not catish. So this is not in U. And also, addition also ruins it because 1 plus 1 is 2, not 1. So if I take two of these guys in there, x1, 1 plus y1, 1, if we add those, we got x1 plus y1 and 1 plus 1, which is 2, which does not equal x1 plus y1, 1, which is what we would need. Or either way, this is not a second coordinate is not a 1, so this is definitely not in U. It doesn't look like a cat anymore. It's a 2, not a 1. So this is definitely not a subspace. It failed all three conditions that I have to check. 0 is not in there. It fails scalar multiplication, is not closed, and is not closed under addition. Not a subspace. 0, 1, say. Oh, you gotta turn your phone off. Hello? That was Billy Baran slowing my roll. So where was I? All right. Oh, don't spill your coffee everywhere. Which is, oh, there's cats fighting each other, chasing each other. So everyone's interrupting in this one apparently. Trying to make videos here, people.